All right, so, whoop, I don't like red. Let's get rid of that. Okay, so another quick little review. All right, same thing. We're going to simplify. All right, I got 3 quick problems for you to do. Okay, so you're still foiling. All right, but something interesting should happen on each of these. All right, so take a minute and foil those out and see what happens. Okay, so let's just look at, well, pick one. Which one you want me to do with you? First one? Okay. Is that okay? All right. So when you say simplify and we're just multiplying, this is just the same thing as we were doing as a review earlier. You're going to distribute your x, and then you're going to come back and distribute your 4. We're foiling. Okay? So we get x squared, but then we get negative or minus 4x. Then we get positive or plus 4x. And then we get negative 16. What happens when we combine the like terms here? The 2 in the middle cancel each other out. They disappear. And so my final answer is just x squared minus 16. Okay? And something similar should happen in all the other problems. Okay? So now you can finish those 2. All right, so let's take a look at these, even if you're not quite finished. All right, so again, we're just double distributing. Distribute the 5x and then distribute the 1. And hopefully you guys get 25x squared, then minus 5x plus 5x minus 1. What happens again? The stuff in the middle disappears, okay? And so my final answer here would be 25x squared minus 1. We okay with that? All right, well then I just threw in a couple of extra letters. All right, so we're going to do the same thing. We're going to do 2a times 2a. Hopefully you guys got 4a squared. Then we're going to do 2a times negative 3b. So you do the numbers and get negative 6. And then the letters you really just put in alphabetical order. Okay? Then we distribute the 3b times 2a. 3 times 2 is 6. And we put the letters in alphabetical order. And then 3 times negative 3 and b times b. And because we put the letters in alphabetical order, it helps us see better that the 2 in the middle cancel out again. Okay? And so my final answer is just 4a squared minus 9b squared. Okay? Well, the answer to every single one of those is what I call a dots. Okay? It's the difference, so it's subtraction, of 2, because it's only 2 terms, squares. Difference of 2 squares. Okay? Because what do I mean by a square? Like what's a square number? What's a square number? 16 is a square number because it comes from 4 squared. Okay? So 1 squared is 1. All right, so let's make a list of our square numbers. Square numbers. Okay, 1 squared is 1. What's 2 squared? 4. 3 squared? 4 squared? 5. 6 squared? 7 squared? 49. We're rolling. 8 squared? 9 squared? 10 squared? Now we'll tell you it's algebra 2, so you're gonna probably want to be familiar with all the way up to 15. Okay, so 11 squared, 121, 12 squared, 144, 13. It's okay if you don't know them all, because you'll be able to use your calculator. All right, you just take the square root and figure out where it came from. All right, 14 is 196, and 15 is 225. Okay, Now, let's talk about square variables, square letters. Square variables. Now, the obvious one, right, is a squared, x squared, b squared, right? But I want you to know that those powers could be higher, okay? To be a square power, and I'm just doing random letters here, the exponent just has to be even. Even exponents are perfect squares, okay? So what we're going to do is we're going to start with the difference of squares, difference of two squares, and we're going to take it back to the double parentheses like we were doing before, okay? Questions on that? All right, so let's write a rule. Let's write a rule. I just need to turn the page here. Well, I can slide it down. All right, so to factor a dots, all right, use the following rule. Okay? Now, I'm using a squared and b squared to represent anything that's a perfect square. Okay? It has to be subtraction. They both have to be squares. Okay? And then it will go to your double parentheses, where you break up the first square term and you put it in the front of each. And then you break up the second square term and you put it in the back of each. And if you look back at your review examples, the signs were always what? There was always, if you look at the three examples we just did, that turned into a dots, one plus and one minus. Does it matter which one you put first? No. Okay? So that's the rule we're going to follow. So for numbers, we have to figure out what times itself gave me that number. So you can really just take the square root of it. And for letters, you just really cut them in half. Okay, that's the easiest way to do it. Okay, so our third section, all right, is to factor. That's just, the directions are just going to say factor from now on. Okay, don't forget, you should always check for a GCF first, but the first couple problems I'm going to give you don't have a GCF. I just want us to practice dots. All right, so I'll put up a couple problems, and then I'll give you a minute to think about them, and then we'll look at them. Okay, so I didn't give you anything crazy here, or try not to. There's no GCFs to worry about at first. All right, so we're going to set up our double parentheses. All right, how do you break up n squared? What do you put in the front of each? N, right? So for letters, you really just cut them in half. All right, but 64 came from what times itself? 8, okay? And if you can't remember your perfect squares, just use your calculator to take the square root of 64. Now, the only way to make it a negative 64 is for one of these 8's to be positive and the other one to be negative. That's also the only way to FOIL them back together and not get a middle term. Okay? All right, how about the second one? C minus 10, and doesn't matter which one you put first, and C plus 10. Good. All right, now, number 3 was sort of backwards, but with dots, you never change the order. Please do not change the order, okay? Because if you did, it wouldn't be a dots anymore. All right, so the 81 is in front. So what's going to go in the front of each? 9. The x is in the back, or x squared is in the back, so my x's are going to go in the back. Okay, that's the only difference there. Do not change the order. Okay? All right, look at this next one. Look at this next one. What's different about it? Anybody notice anything different about it? It's a plus. It's a plus. That means it's not the difference of two squares. Well, it doesn't factor if it's not the difference of two squares. So unless it has a GCF or something else, this is prime. Unless it has a GCF or something else, all right, this is prime. So let me give you a similar one, make sure you can. All right, what if I said that? First of all, does plus automatically make it prime? No, it does not. You still have to look for a GCF first. Do these two numbers have something in common? Yes. 3 goes into both of them. What's left? Very good. All right, but that is not a dots. It's not subtraction, and 11 is not a perfect square. In this case, all that means is we're done. It's not prime because we did take some sort of factor out, but we are done. Okay? All right, let's bump it up a little bit. All right, 1 minus 49y squared. Do we have a GCF here? No. Is it subtraction, first of all? Okay. Is it a dot? Are they both squares? Think about our square numbers and letters. Are they both squares? Yes. But you cannot change the order. Okay? The 1 is in the front. 1 comes from 1 times 1. It has to stay in the front. Then we put 1 plus and 1 minus. Where does 49 come from? Keith, you with us, bud? Where does 49 come from? 7, and then how many y's do I put with each? Just the 1. Okay? Questions on that? All right. What if I have numbers with both, like other than a 1? Is that okay? Yeah, I just square root. I just figure out what each number gives me and try not to mix them up. All right? 16 comes from 4 times 4, and the n goes with it. 1 plus and 1 minus. And where did we say 225 came from? 15. Good. All right. Do you think it's okay if there are letters with both squares? Yes, as long as they are squares. As long as they are squares. So 4 comes from 2 times 2. How about h squared? What do I break that into? H and h. All right, where does 25 come from? 5 and 5. But for g to the 4th, I got to figure out how to cut that into 2 equal things. So you just cut it in half, and we get g squared on each. Okay? All right, I'm just trying to give you an example of lots of different things. All right, I just got a couple more for us. Come on, there we go. All right. Skipping around. All right, how about that? How about that? That one's a little different. Because technically, what should you always look for first? GCF. This one actually has a GCF. What do you think goes into 8 and 72? What might be the biggest number? 8. Very good. So if I take that out, then I have n squared minus 9p squared. Do I now have a dots? Yep. Okay. And then make sure that the 3 and the p go together. Okay. All right, I do want you to watch out for one thing here. All right, you have to be real careful. All right, in this problem, everything is a perfect square, but what should you always look for first? GCF. You really need to look for that GCF first. And even though they are already perfect squares, they have a 4 in common. They have a 4 in common. You have to take that GCF out first. Luckily, we still have a dots, so we need to keep going. Make sure you keep that GCF in front. Okay? All right, I got one final problem for us. We can do it. You guys have been awesome today. I'm going to really kick it up, though. I'll really kick it up here. Amazing, you all right? All right, last one for the day. I can tell you now that 81 and 16 do not have a GCF. Okay? Do we have perfect squares? Yes. Okay? Exponents are perfect squares if they're even, so we're good. All right. What's going to go in the front of each? 9x squared. Then 1 plus and 1 minus. What's going to go in the back of each? 4y to the 4th. Now, this problem is not done. Why? What do we have more of? We got more, well, all of them have more squares. But remember, you can only factor the ones that's dots, difference of 2 squares. So the first one has a bunch of squares, but it's not subtraction. So that one stays the same. But the second one has more squares, and it is subtraction. So we have to keep going and break that one down again. So that second piece is another dots. All right, there is 1, maybe 2 on the homework that you have to do more than once. All right, so we're going to get a 3x plus 2y squared and 3x minus 2y squared. But do we have any more dots? No. Okay, so there we go. We're done.